Hi everyone, right? Okay. So up till now, we have completed lecture 5, right? See, in the previous lecture I have wrongly written lecture number 4, but that is lecture number 5. Okay, so please correct that one. So previous lecture is lecture number 5 and this is lecture number 6. Okay, so we are dealing with the third chapter, that is coordinate systems. So in that we are going to start a cylindrical coordinate system, right? So in the previous session we have completed the rectangular coordinate systems, right? Okay, so from this lecture we are going to start the cylindrical coordinate system, right? Okay. So here the coordinates in cylindrical coordinate system are nothing but rho, phi and z, rho, phi and z. So first of all we will see how we can construct a cylinder. So if you know how to construct a cylinder, okay, then you can easily visualize this cylindrical coordinate system. Then you can easily understand this cylindrical coordinate system. Okay, so first of all you have to know how to construct a cylinder, right? So I will tell you 2 ways to construct a cylinder, so you can follow anything, right? Okay, now see here, suppose if I consider, I am considering an axis, let us say I am considering an axis here. So let us say this is z axis, let us assume this is z axis, right? Okay. So now I am considering a point, here which is at a normal distance, rho from this z axis. I am considering a point, here which is at a normal distance rho from the z axis, right? Now if I ask you what is the locus of all the points which are at the same normal distance rho? What is the locus of all the points which are at the same normal distance rho? So that means if you try to join all the points which are at the same normal distance rho from the z axis, then what is the shape you are going to get? So that's what I am asking, right? Okay, so let's do that here, So here this is at a distance rho, right? So if I draw a line here, straight line like this, understood? Okay. So if I draw a line here like this, right? Okay, now each and every point on this line here, each and every point on this line is at the same normal distance rho or not? Each and every point on this line is at the same normal distance rho, right? Okay. So I want the locus of all the points in 3-dimensional space which are at the same normal distance rho. So for that what we can do? So take this line, okay. So all the points on this line are at the same normal distance rho, right? So now if I take this line and if I rotate this line here, about this z axis, then what I am going to get? I am going to get all the points which are at the same normal distance rho or not? Yes or no? So if I rotate this line, if I take this line and if I rotate this line about this z axis, then what will happen? So this point is going to trace what? It is going to trace a circular path like this. So similarly this point is going to trace a circular path like this. So like that all the points on this line are going to trace a circular paths like this. Understood? So if you join all these points here, you are going to get what? You are going to get a shape of what? A shape of the cylinder. you are going to get the curved surface of the cylinder. So each and every point on this surface, is at the same normal distance, rho, isn't it? Okay, so each and every point is at the same normal distance rho, right? Okay, okay. So this is how you can form what? You can form the, or you can construct a cylinder, right? This is how you can construct a cylinder, right? So what we have done? You have considered a point which is at a normal distance rho from the z-axis, right? Now we have determined the locus of all the points which are at the same normal distance rho from the z-axis. Okay, so that locus is nothing but what? That locus is nothing but this curved surface area of the cylinder. Understood? So this is one way to construct a cylinder. So this is nothing but what? This is nothing but, I can say this is nothing but locus of all the points, which are at the same normal distance, rho, from the z-axis, forms a curved surface area of cylinder, Understood? So it is going to form the curved surface of the cylinder, right? So this is one way to construct a cylinder, right? Okay. So next, see here. Next, another way to construct a cylinder is, if I have given to you some 100 circular rings here, each is of same radius. I have given 100 circular rings to you, each is of same radius, and ask you to construct a cylinder. Then what you will do? So you place one circular ring, and above that you place another circular ring, above that you place another circular ring. So like that you are going to place all the circular rings one upon the other continuously up to some height h. Understood? Now this is going to form what? This is going to form the curved surface of the cylinder. Now tell me, what is the curved surface area of the cylinder? What is the curved surface area of the cylinder? Tell me. So how you have constructed? By placing the circular rings one upon the other up to some height h. So each circular ring is having a perimeter of what? 2 pi rho. Let us assume the radius of circular ring is rho. Understood? Then the perimeter of each circular ring is nothing but what? 2 pi rho. So such a type of circular rings you have placed up to some height h. Understood? Then what is the curved surface area of the cylinder? Is nothing but what? 2 pi rho times h. So 2 pi rho times h. Okay. So each circular ring perimeter is nothing but 2 pi rho. So like that you have placed such type of circular rings one upon the other up to some height h. So 2 pi rho times h is going to give you what? Is going to give you the curved surface area of the cylinder. So there is no need to remember the formulas and all. Okay. So if you visualize how to construct a cylinder, so each and everything is going to be crystal clear, right? Okay. Okay. So what I have told, how we can construct a cylinder? We can construct a cylinder by placing the circular rings, one upon the other. So like this here, like this. So by placing the circular rings one upon the other, we can construct a cylinder, right? Okay. Okay. So now see here. Right. Now if I join all the centers of these circular rings, I am joining all the centers of this circular ring. So if I join all the centers of this circular rings, you are going to get what? You are going to get a straight line. Understood? So I am drawing that straight line here. I am drawing that straight line here. So I am joining all the centers of the circular rings. So if I join all the centers of the circular rings, I am going to get a straight line like this. Okay, so this line I am calling it as z-axis. This line I am calling it as z-axis. Understood? Okay, so how we got this line here? How we got this line? By joining the centers of what? By joining the centers of all the circular rings. By joining the centers of all the circular rings, we got a line which is called as which we named it as z-axis, and this axis is called as what? Is called as axis of the cylinder. This axis is called as axis of the cylinder. Why it is called as axis of the cylinder? We will see that. Right? Okay. Okay. So by joining the centers of all the circular rings, we got a line. So that line we are naming it as z-axis, and this z-axis is nothing but what? Axis of the cylinder. Axis of the cylinder. Okay. Okay. So how we got this axis of the cylinder? By joining all the centers of circular rings, right? Okay. Now here, okay, now here I am drawing another axis, so that is x-axis, and here I am considering another axis, that is y-axis. So x-axis, y-axis and z-axis, right? Okay. Okay. So now see here. So now in order to represent, so this is another way of constructing a cylinder. Now in order to represent any point, on the surface of the cylinder, we need 3 coordinates. So what are those 3 coordinates here? Are nothing but rho, phi and z. Rho, phi and z. Okay. So these are the 3 coordinates needed in order to represent any point on the surface of the cylinder. So we have to understand what do we mean by rho, and what do we mean by phi, and what do we mean by z, and what is the differential length along rho, what is the differential length along phi, what is the differential length along z, and also we have to understand what is the range of rho, what is the range of phi, and what is the range of z. So you have to get familiar with these things, right? So once you understand these things, then you can easily understand this cylindrical coordinate system, right? Okay. Okay. So the first point here is in order to represent any point, first point write down, in order to represent any point on the surface of cylinder, we need 3 coordinates. That is rho, comma, phi and z. Okay. So these are the 3 coordinates we need in order to represent any point on the surface of the cylinder, right? Okay. So now we will see one by one. What do we mean by rho, and what is the range of rho, and what is the differential length along rho? So these things we will see, right? Okay. So I am moving on to next page here. So next write down for rho here. Rho. Okay. So rho is called as a radius of the cylinder. So first write down for rho. Okay. So it is called as a radius of the cylinder. So rho is called as radius radius of the cylinder, radius of the cylinder. Okay, so I am going to copy this figure. Right. Okay. So rho is called as a radius of the cylinder, radius of the cylinder. Right. Okay. Right. So how it is defined? How it is defined is a it is the normal distance here. Rho is the normal distance. So you can write in this manner, right? Okay. So rho is the normal distance. Rho is the normal distance measured. Rho is the normal distance measured, or I can say rho is the normal distance. Rho is the normal distance from the z-axis. Rho is the normal distance from the z-axis to any point on the surface of what? On the surface of the cylinder. So write down this one here. Write down this one. I will explain this. Right. So rho is called as radius of the cylinder, and this rho is nothing but what? Rho is nothing but the normal distance. The normal distance measured with respect to z-axis. The norm, or I can say the normal distance from the z-axis to any point on the surface of the cylinder. Rho is the normal distance from the z-axis to any point on the surface of the cylinder. So which means see here. So if I consider this line here, if I consider this line, okay, so this is nothing but what? This is nothing but the normal distance from the line to this point. If I consider a point here, so if I draw a normal line from z-axis to this point, this is called as what? This is called as rho. Right. Now if I consider a point here, so if I draw a normal line, from the z-axis to this point, is called as what? Is called as rho. And if I consider some point here, if I draw a normal line from the z-axis to this point, is called as what? Rho. If I consider this point, the normal distance from the z-axis to this point is called as what? Is called as rho. So if I consider this point, the normal distance from the z-axis to this point is nothing but rho. So the normal distance from the z-axis to this point is nothing but what? Is nothing but rho. So the normal distance from the z-axis to any point on the surface of the cylinder, is called as what? Is called as rho. Okay. So which means I can simply say that the radius of each and every circle here, if I draw the radius of this circle, okay, the radius of this circle itself is nothing but what? Is nothing but radius of the cylinder. And similarly, if I consider the radius of this circle, okay, so if I consider the radius of this circle, so the radius of this circle is also nothing but what? Is also nothing but rho only. Understood? Okay. So which means you can remember the rho in a simple manner like this, right? So that is the radius of each and every circle. The radius of each and every circle is nothing but what? Is nothing but rho. Right. So how we have defined rho here? Rho is the normal distance from the z-axis to any point on the surface of the cylinder. So it is nothing but what? It is nothing but the radius of each and every circle. The radius of each and every circle. Understood? And if you observe all these circles here, right, so these circles are parallel to what? Are parallel to xy plane. This is xy plane or not? Okay, so these circles are parallel to xy planes. Understood? Okay. Yeah. So that's what you have to observe here, right? Okay, fine. 5, right? Okay, so we have defined rho. So rho is the normal distance from the z-axis to any point on the surface of the cylinder. So that is called as rho. Next, what is the range of rho? What is the range of rho? Next, we have to see what is the range of rho. Right. See here, as rho decreases here, as rho decreases, what will happen? The size of the cylinder is going to decrease or not? Yes or no? So as rho decreases, the size of the cylinder is also going to decreases, and as rho increases, the size of the cylinder is also going to increase. So which means as rho varies, the size of the cylinder is going to vary. Understood? So that means what is the range of rho here? What is the range of rho? So you can make the size of the cylinder up to what? Up to 0. You can make it as minimum as 0. Understood? And you can extend the size of the cylinder up to what? Up to infinity. You cannot make it exactly infinity, but you can extend the radius up to infinity. So you can make it exactly 0. Yes or no? The radius of the cylinder, you can make it exactly 0, and you can extend the radius of the cylinder up to what? Up to infinity. So as rho varies, the size of the cylinder is going to vary, and you can vary the size of the cylinder from 0 to what? From 0 to infinity. You cannot make it exactly infinity, but you can extend it up to infinity. So which means the range of rho is what here? Next point is a range of rho. So range of rho. So what is range of rho? Range of rho is from where to where? From 0 to what? From 0 to infinity. You cannot make it exactly infinity, but you can make it exactly 0. Understood? Okay, so this is the range of rho. So here you can make a note. So that is, as rho varies, the size of the cylinder, is going to vary. As rho varies, the size of the cylinder is going to vary. Okay. So you can make a note of this point. So as rho varies, the size of the cylinder is going to vary, and hence the range of rho is from where to where? From 0 to infinity. Right? Okay. Next, see here. Next, one more thing. As you move along rho here, I will use another color. Okay. So as you move along rho, okay, so as you move along rho, you are moving along what? You are moving along a straight line path. Yes or no? So if you are moving along a straight line path, what is the differential length along rho? I can write. See, in rectangular coordinate system, I have considered a differential length along x as what? As dx ax cap. Yes or no? Okay, so here as I move along x direction, I am moving along what? I am moving along a straight line path. So if I am moving along a straight line path, I can simply represent this as what? I can simply represent this as dx ax cap. Now here also, as I move along rho here, I am moving along simply along a straight line path, and hence I can represent the differential length along rho as what? As d rho. And what is its direction here? Its direction is along arrow cap. So the unit vector along rho I am representing with arrow cap. Okay, so the differential length, if I consider a small differential length, along rho, I can represent this as what? D rho arrow cap. So this is the small differential length along rho, right? Okay. So the next point is the small differential length along rho. So differential length along rho is what? Is d rho arrow cap. Understood? Okay, so these are the things we have to learn here. So I have given the definition for rho, and we have seen what happens as rho varies, and from that we have decided the range of rho, and then after that we have determined the differential length along rho. So this is all about rho. right? Okay, so similarly we try to analyze phi. So what do you mean by phi? So the next parameter is nothing but what? Is nothing but phi. Okay, okay. So here for this I am going to copy this diagram. Right. And one more point here, see, I said this z-axis is called as what? Is called as axis of the cylinder, So why we are calling it as axis of the cylinder here? Because the normal distance from this z-axis here, to any point on this surface, of the cylinder is constant. Yes or no? That is nothing but rho. The normal distance from the z-axis to any point on the surface of the cylinder is constant. That is nothing but what? That is nothing but rho. Understood? So that's why it is called as what here? Axis of the cylinder. See, this condition is not satisfied if I consider any other line that is parallel to z-axis. See, if I consider some other line, like this, understood? Okay. So if I consider some other line like this, right? So the normal distance from this line to any point on the surface of the cylinder is not constant, isn't it? Okay, so the distance from here to this point is different. The normal distance from this point to here is different. Okay, so that's why we cannot call it as what? Axis of the cylinder. So what do you mean by axis of the cylinder? The normal distance from this axis to any point on the surface of the cylinder is constant. So that's why we call it as axis of the cylinder. So that property is not satisfied by any other line, that is parallel to what? That is parallel to this z-axis. Understood? Okay. So that's why we should not consider this as a axis of the cylinder. We have to consider this z-axis as the axis of the cylinder. So how we got this axis of the cylinder? By joining the centers of all the circular rings. Understood? So remember that point. Right. Okay. So next we will see phi. Right. Okay. So now see here. So I am considering this circular ring. That is present in xy plane. Right. Okay. So now here I am considering a point here. So here I am considering a point. At this location I am considering a point. Right. So the normal distance from the z-axis to this point is nothing but what? Is nothing but rho. Right. So this point I can represent it as what? Rho, comma. Okay, and this point is lying in xy plane. So that is, it is lying in this plane is nothing but what? Z is equal to 0 plane. So this plane is nothing but z equal to 0 plane. So z value is nothing but what? Z value is nothing but 0. Okay, so let us say this is point P1. Next, I am considering some other point. Here. Understood? So this point is also at the same normal distance rho, and this point is also lying in z equal to 0 plane only. So this point I am considering it as P2. So this point P2, how I can represent? It is at the same distance rho, and z value is 0. Now I want to differentiate between these 2 points here. Okay, so here the coordinates for this point here, it is nothing but rho, and here 0, and for this point also it is rho and 0. Right. Now how I can differentiate between these 2 points? See here, as I move from this point to this point here, as I move from P1 to P2, I am moving along am I moving along a straight line path or am I moving along a curved path? Tell me. As I move from P1 to P2, as I move from P1 to P2, am I moving along a straight line path or am I moving along a curved path? Tell me. So you can easily see that you are moving along what? You are moving along a curved path. Okay, so in order to represent the movement along the curved path, you need what? You need an angle. Yes or no? You need an angle. So that angle is nothing but phi. That angle is nothing but phi. Right? Okay. Okay. Here. So now this angle phi is defined as what here? This angle phi is the angle. Phi is the angle between x-axis and rho, and it is measured with respect to what? With respect to x-axis in anti-clockwise direction. So this is the definition of phi. So we will see what do you mean by this. So what we are defining here, phi means so phi is the angle between x-axis and rho. So here I have considered this point here. Here I have considered this point. Right. Okay. So phi is the angle between x-axis and rho. So whenever I consider this point, okay, so draw the radius here. Draw the radius. So that is nothing but rho. So now the angle between this x-axis and this rho, I am considering it as phi 1. I am considering it as phi 1. Right. Okay. So I am considering it as phi 1. So this is the angle between x-axis and rho for this point. Next, if I consider this point here, right. So here I am drawing the rho. The normal distance from the z-axis to this point is nothing but rho. Now for this rho, the angle between x-axis and rho, the angle between the x-axis and this rho, this I am considering it as what? This I am considering it as phi 2. Okay. Now this coordinate I can write it as what here? So this point P1 is at a normal distance rho, and it is lying in z is equal to 0 plane, and it is at an angular displacement of phi 1 from the z axis. It is at an angle of phi 1 from x axis. Sorry. This point P1 is at an angle of what? It is at an angle of phi 1 with respect to what? With respect to x axis. So this point I can represent here as phi 1. So rho comma phi 1 comma 0, and this point P2. So as I move from this point to this point here, I am moving from this point to this point. So I am moving along the curved path. So at this point, if you want to represent the coordinates, so this point is at a normal distance rho, and this point is lying in z is equal to 0 plane, and this point, if you draw rho, then the angle between x-axis and this rho, is nothing but what? Is nothing but phi 2. So that means this point is at an angle phi 2. It is at an angle phi 2 with respect to what? With respect to x-axis. So now we can differentiate between these 2 points. Understood? Okay. Okay. So now if you consider another point, some other point here, then the angle will become some phi 3. Understood? So that means as you move along this circumference of the circle here, the phi value is going to change. Understood? Okay. So which means as you vary phi, you are going to move along the circumference of the circle. Understood? And hence, what is the range of phi here? The range of phi is from 0 to 2 pi. So phi is the angle between x-axis and rho. So let us say this is x-axis, okay, and this is rho. So here you are having rho. Right. So the angle between x-axis and rho is nothing but what? Is nothing but phi. right? So as you verify here, you are going to move along what? You are going to move along the circumference of the circle. You are going to move along the circumference of the circle. Understood? And hence the range of phi is from 0 to 2 pi. Understood? So I hope this point is crystal clear, right? Okay. So here what we have concluded, as you verify, so as you verify, you are going to move along the circumference of the circle. You are going to move along the circumference of the circle. Okay, and hence the range of phi, is from, is what here? Is 0 to what? 0 to 2 pi. See here, remember one thing. So whenever rho is, if I consider a point here, so rho will be lying here. Rho is along what? Rho is along x-axis. Okay, so whenever rho is along x direction, okay, so what is phi here? Phi is equal to what? Phi is equal to 0 degrees. Now as you move from this point to this point, understood? Okay, then you have to draw rho here. The angle between this x-axis and rho is nothing but what? Is nothing but phi. So as you move along this circumference of the circle, the phi value is going to increase, So as phi goes on increases, okay, increases, and again if you reach to this point, it will become what? 360 degrees. Understood? So 0 degrees and 360 degrees both are going to represent what? Both are going to represent the same point. And hence whenever you are putting equality here, you should not put equality here. Okay, why here? Because 0 and 2 pi both represents what? Both represents the same point, and hence whenever you are putting equality here you should not put. Or you can write in this manner, phi is varying from 0 to what? 0 to 2 pi. So in this manner also you can write. Okay. In some books they have put equality here, and here also they have put equality. So we can't do anything about those textbooks. Understood? Okay. But actually speaking, this is the logic here. Okay. So 0 and 2 pi both represents the same point. You should not include the same point twice. So that's why if you put equality here, you should not put equality here. Or if you put equality here, don't put equality here. Understood? Okay. So phi is the angle between x-axis and rho, and it is measured with respect to x-axis in which direction? In anti-clockwise direction. And the range of phi is varying from where to where? From 0 to 2 pi. Why it is varying from 0 to 2 pi? As you vary phi, you are going to move along the circumference of the circle, and hence the range of phi is from 0 to 2 pi. Understood? Okay. So these are the points we have concluded. So as phi goes on increases, you are going to move along the circumference of the circle in anti-clockwise direction. Right? Okay. So 1 minute. Okay, right. Okay. So one more thing, see here, we have to write the differential length along phi. So how we can write that? See here. So here we are having x-axis, and here we are having y-axis. So this circle I am considering here. So I am considering this circle. Okay, so this circle is in z is equal to 0 plane. So this is z is equal to 0 plane. I am drawing like this. Okay, so here you are having x-axis and y-axis. So here I am drawing x-axis. Let us consider this as x-axis and let us consider this as y-axis, right? Okay, so I am drawing separately like this. I have drawn this circle here, that's it, right? Okay, so this is x-axis, y-axis I have considered. So now between x-axis and y-axis we are having here rho, yes or no? So here we are having rho, right? So here I am considering rho, so this radius is rho, right? So this point I am considering it as P1, right? And I am considering another point, let us say this point, so this point is P2, okay? Okay, yeah. So this radius is also nothing but what? Rho. And the angle with respect to x-axis, the angle between x-axis and rho is nothing but phi. So let us say this angle is phi1, and the angle with respect to x-axis and this rho is nothing but what? Let us say this angle is phi2, right? Okay, okay. So then what is this angle here? This angle is nothing but phi2 minus phi1. So I am assuming that phi2 minus phi1 is tending to 0. Phi2 minus phi1 is tending to 0. So that means this difference between phi2 and phi1 is very small. So I can replace this with what? I can replace this with d phi. So since the difference between phi2 and phi1 is very small, I am considering this small angle as a differential angle, so which I am representing with d phi. Understood? Okay, okay, yeah. So now as you move from P1 to P2, you are moving along what? You are moving along this arc. Understood? Okay, okay. So now here you have to determine this differential arc length here. What is the differential arc length? Tell me. So this is the circle, right? Okay, so this is the arc length. This represents, as you move from P1 to P2, you are moving along a curved path. Like this. Now, what is the differential arc length here? What is this differential arc length? The differential arc length is nothing but rho into what? Rho into d phi. Yes or no? Okay, so this rho into d phi is nothing but this differential arc length. So rho into d phi is the differential arc length. So as you vary phi from P1 to P2, you are going to move along a curved path. So the small differential arc length is nothing but what? Is nothing but rho d phi. And one more thing I have told that we are measuring the phi in which direction here? In anti-clockwise direction. So that means we are measuring the phi in anti-clockwise direction, right? Okay, okay. We are measuring the phi in anti-clockwise direction. So remember that point, right? Okay. So now what is the direction? What is the direction of this arc here? What is the direction of this arc? See, the direction of any arc or the direction of any curve is given by what? Is given by the tangent drawn to that arc, right? Okay. So now here we are having this arc. So we can draw the tangent to this arc in two ways. So one is what? One is in anti-clockwise direction like this, and another one is in clockwise direction like this, right? So we can draw the tangent to this arc in two ways. One is in anti-clockwise direction and another one is in clockwise direction. But in which direction we have to draw? I have already told that we are measuring the phi in which direction? In anti-clockwise direction. So you have to draw the tangent to this arc in anti-clockwise direction. So this we call it as a phi cap. So this differential arc length is nothing but what? The magnitude of this differential arc length is nothing but rho d phi, and the direction of this differential arc length is given by the tangent drawn to this arc in anti-clockwise direction. So that we have named it as a phi cap. So it is nothing but rho d phi a phi cap. Understood? So this is the small differential arc length along phi. So the small differential arc length along rho is nothing but what? Along rho is nothing but what? D rho a rho cap. Whereas the small differential length along phi is nothing but what? Rho d phi a phi cap, where a phi cap is the tangent drawn to the arc in which direction? In anti-clockwise direction. So that is going to give you, A phi cap is going to give you the direction of that arc at that point. Understood? Okay. Okay. So see here. So the differential arc length. So next point is the differential arc length along phi. The differential arc length along phi is nothing but what here? Is nothing but rho d phi A phi cap, where this A phi cap is the tangent drawn to arc in anti-clockwise direction. Understood? So this is the differential arc length along phi. Understood? Okay. So I have given the definition of phi. So it is the angle between x-axis and rho, and it is measured with respect to x-axis in anti-clockwise direction. So as you vary phi, or as you go on increase phi, you are going to move along the circumference of the circle, right? And hence the range of phi is from 0 to 2 pi, and the differential arc length along phi is nothing but what? Rho d phi A phi cap, where A phi cap is the tangent drawn to the arc in which direction? In anti-clockwise direction. Understood? Okay. Okay. So this is all about phi. So I hope you have understood what do you mean by rho and what do you mean by phi, right? So next one last thing, that is nothing but what? Z, right? Okay. Okay. So now see here. See, the definition of Z here, the definition of Z will remain same as in case of what? As in case of rectangular coordinate system. Okay. So there is no difference between Z. Okay. In rectangular coordinate system and cylindrical coordinate system, the definition of Z will remain same. There is no change in that, right? Okay. But anyway, here in cylindrical coordinate system, what happens as Z varies? So that's what we are going to see. Okay. Right. So now let us consider a point here. Right. So this is rho, and let us say this angle is phi 1, right? So this point is nothing but rho comma phi 1 comma 0, right? Okay. And this plane is nothing but what? Z is equal to 0 plane. Now if I move this point from this point, to here, okay, so if I move this point from here to here, so what is going to change? See, the normal distance from the Z axis to this point is still what? It is still rho, and the angle with respect to x axis. So just draw a parallel line to x axis. So the angle with respect to x axis is still what? It is still phi 1 only. So this point is nothing but rho comma what? Rho comma phi 1. So what is the only change here? As you move from here to here, there will be no change in rho and there will be no change in angle phi 1. What is the only change? Z value is going to increase. Yes or no? So let us say this plane is let us say Z is equal to Z1 plane. Let us say this is Z equal to Z1, or you can say Z equal to 5, Z equal to 6, or whatever it may be. Understood? Some Z value, I am considering it as Z equal to Z1, then this point will become what? Then this point will become Z1. So now if I move this point further, to this location, understood? So now also what will happen? This point here, draw a parallel line to x axis. This point, this angle will be phi 1. So this point still you can write it as rho comma phi 1 comma. So let us say this plane is Z equal to Z2, where Z2 is greater than Z1, right? If it is Z equal to 5, let us say this is Z equal to 10 or something. So this point will be what? This point will become Z2. Understood? So as you move as you move from this point to this point, what is happening? what is happening? Only z value is increasing. Z value is increasing. So that means as z value goes on increases here, as z value goes on increases, as z value goes on increases, the height of the cylinder is also going to increase or not? Yes or no? So you can increase the z value in upward direction up to plus infinity, or you can increase the z value in downward direction up to minus infinity. In both the cases, the height of the cylinder is going to change. Understood? So that means as you vary z here, as you vary z, the height of the cylinder is going to vary, and you can vary the height of the cylinder from plus infinity to what? From up to from plus infinity to minus infinity. Understood? You can extend it up to plus infinity in upward direction, or you can extend it up to minus infinity. You can extend it up to minus infinity in downward direction. Understood? Okay. So the range of z here, the range of z is from where to where? Minus infinity to plus infinity. You cannot make it exactly infinity, so that's why we are not putting equality here. So the range of z is from minus infinity to plus infinity, same as what? Same as in rectangular coordinate system. So now here, as you vary z here, as you vary z, height of the cylinder, height of the cylinder is going to vary. Height of the cylinder is going to vary. Height of the cylinder is going to vary. Right? Okay. And one more thing here, what is the differential length along z here? See, as you move along z, you are moving along what? You are moving along a straight line path. You are moving along a straight line path. So if you are moving along a straight line path, you can represent the differential length as what here? The differential length along z is nothing but what? Is nothing but simply dz az cap. Same as what? Same as rectangular coordinate system. There is no change in that. Right? Okay. Okay. So as you vary z, the height of the cylinder is going to vary, and the differential length along z is nothing but what? dz az cap. Right. So we have studied about rho. It is the normal distance from the axis of the cylinder to any point on the surface of the cylinder. Right. As you vary rho, the size of the cylinder is going to vary, and hence the range of rho is from 0 to infinity. Understood? And the differential arc length along rho is nothing but d rho aero cap. Next we have studied about phi. Phi is the angle between x-axis and rho. It is measured with respect to x-axis in anti-clockwise direction. As you vary phi, you are going to move along the circumference of the circle, and hence the range of phi is from 0 to 2 pi. And the differential arc length along phi is nothing but rho d phi a phi cap. Next, as you vary z, next we have studied about z. Right. The definition of z will remain same as in case of rectangular coordinate system. So as you vary z, the height of the cylinder is going to vary. So you can extend the height of the cylinder in upward direction up to plus infinity, and in downward direction up to minus infinity, and hence the range of z is from minus infinity to plus infinity. Isn't it? Okay. And the differential length along z is nothing but dz az cap. So this is what we have studied. Okay. So I hope each and everything is crystal clear. So you have studied about rho, phi and z. So in order to represent any point here, in order to represent any point on the surface of the cylinder, you need these three coordinates, that is rho, phi and z. So with the help of rho, phi and z, we can represent any point on the surface of the cylinder. Understood? Okay. Okay. So I hope all these points are crystal clear here. So with this, I am ending up this session. With this, I am ending up this session. Right. So we will continue this cylindrical coordinate system. We will continue this. We will continue this cylindrical coordinate system in the next lecture. Right. Okay. Okay. So I hope up till now it is crystal clear. Right. So we will continue this cylindrical coordinate system in the next lecture. Right. So okay then, thank you for watching it. So take care. Bye bye.